It's okay. You'll be fine. That's the microphone. It doesn't have to be right next to your face. The dot's on the other side. But it does have to be like belly button or higher. So if you just hold it.
So they can hear just my voice?
No, it'll pick up. As long as you're standing next to each other, it'll pick up both of you just fine.
That's weird. Okay.
Do you start now?
Yeah. Physics of a
like
Teeter-Totter by Cassie and Tiff.
Okay, what a teeter-totter used to be like. Teeter-totters were much more taller and installed on a black top. They were also made of wood and may have gave you splinters. A teeter-totter is also known as a seesaw.
The simple machines of a teeter-totter. There's 3 types of levers, which are pulley, a wheel and axle, incline plane, screw, and a wedge.
The first class lever, it is a first class lever because the fulcrum is in the middle of class. One lever has a fulcrum placed between the effort and the load. The movement of the load is in the opposite direction of the movement of the effort. This is the most typical lever configuration, and that just kind of shows the effort load.
These are the measurements that were given to us of this teeter-totter. The width is 23 inches and the length is 10 feet 7 inches. The center of it is 58 inches.
What is a teeter-totter? It is a long, narrow board supported by a single pivot point, most commonly located at the midpoint between both ends. As one goes up, the other goes down.
How it works. If 2 children are roughly the same weight and they're each sitting on the ends of the teeter-totter at points, I don't know what the hell that word is, from the center, the whole thing will be balanced because they're exerting equal and oppositely directed forces, which is gravitational force or weight. However, if one child is significantly heavier than the other, the heavier one will have to move closer to the center to achieve this. And altering the force's distance from the fulcrum obviously affects the rotational force exerted on the other side.
So like we said, to balance it, if there's like a 115-pound kid, I don't know how much you guys actually weigh, but a 115-pound kid on one end of the teeter-totter and a 140-pound kid at the other end, the 140-pound kid will have to move forward a little bit so that the weight is balanced. Like Laddie had to move up more, because if you can tell, like if they're at the ends, Laddie will like hold her down.
The dangers of a teeter-totter. Although a playground teeter-totter can be a great learning experience as well as a source of fun, it can also be potentially dangerous. Sudden shifts in weight may cause the device to become so unbalanced that a child could fall off, sustaining damage, and this is why it's important to be careful.
Differences between first, second, and third class lever. First class, the fulcrum is located between the force and the resistance. Example would be a teeter-totter. Second class, resistance is between the force and the fulcrum. Example, wheelbarrow. Third class, the force is between the resistance and the fulcrum. And example, fishing pole. And that's like how they look like. A teeter-totter is that an effort goes down, and then second class is in the load's in the middle, and then third class is like a fishing pole where it's heavy at the end, and then the fulcrum's at the end. And then I have other stuff. 1 second. And then is it gonna work? No. Okay, and then that's the picture or the drawing, I guess. And then there's a video. And there's the video. And any questions? Anyone?
All right, that's it.
You need to do better than that.
No,
Questions?
No one wants to ask questions.
They understand. Yeah, I just showed it to you. Do you want to see it again?
Yeah. Put it on there. Any other questions?
Yeah.
Yep, pretty much.
Yeah. We like took some of their stuff and put
The things we changed and added to is like
like,
the dangers and something else.
we put a different size of what a teeter-totter is, how it works. We put like all different information, like we wrote it all. Then we put a slide with balance and yeah, the dangers.
So like we added
and then we also
3 or 4
did,
sides.
what the difference between the first, second, and third class lever was. And then we showed pictures to show the difference.
Any other questions? That's it. We're done.
Hang on 1 second. The measurements were given to you. Do you think they were accurate?
I think so.
I don't know, did Anna or Laddie measure it?
Did you check them?
Nope, we did not.
Did you question them?
Nope.
Should you have questioned?
I
could've.
guess probably.
It looks
Well,
like you guys.
I think it's pretty accurate.
I thought they would have been.
I think they probably are too. I just want to know if you actually thought about it. Did you
I mean,
question
yeah,
well,
we
like, I
thought
looked
about
at
it, but
and what the measurements were seemed like they'd be right.
it? Okay.
Like, you know,
It looked like you
Didn't
worked
seem
together
odd.
on this.
yeah.
Yep.
Not one of you did it all and the other one just kind of sat there.
Well, I typed, but Tiffany didn't find information.
Class, was this something that they understood for the most part? Okay.
here's your deal back. I don't know what.
Hang on.
Alright.
We still questioning.
Ask questions.
I just got done saying we're still questioning.
Alright.
We've been questioning.
Alright.
There was an on-site demonstration. Did you use it?
The demonstration, the video.
Yeah, you had a video.
Yeah. We
Did
used,
you use that video?
yeah.
And how did you use that video?
You mean how I played it?
Yeah.
We used it from the other people that had it.
Yeah, it wouldn't let me move on to my slides, so I didn't take it from their slides.
And that's fine. And it projected and it worked and they went up and down. Is that a demonstration?
Yeah.
So what's the difference between a demonstration and something I saw? Did I see kids outside on the playground when we went outside earlier today? Yeah. Is that a demonstration then? There's kids all over the swings. Were they demonstrating?
Well, I didn't know we had to make our
Was this a
own.
demonstration or was this a show?
Both.
And what's the difference between a demonstration and a show? Did they? Did you explain what was going on as the people went up and down on the teeter-totter?
Well, I didn't. Okay.
Well, she
yes.
said that kid's going up and that kid's going down because he's fatter. And
I
she's-
said because Laddie had to move
skinny.
forward more because he's
Yes,
heavier.
you did.
Yeah, and I said that's what was happening.
Is that a demonstration? Yes, it is. Did we get that the
Yes, if we
first
did
time
this
that we
wrong.
saw that little piece of video, the first presentation, a couple of days ago?
Yes.
Are you listening?
Sure, but yeah.
You're not.
I said one thing. Oh my god. Okay.
Earlier this week. Okay. We had that same one? Or was it late last week? Did we get an explanation? Did we get an actual demonstration or did we just get a show? And here's some people going up and down on a teeter-totter. So it was good this time. It wasn't last time. That's a good thing to know. the difference between those two. Do we have to do the practice and gather feedback on this one?
No. I'm pretty sure like something else also could be
Yeah. I'm pretty sure we're gonna wanna eliminate that from this one, since we had the short turnaround.
No.
It doesn't matter if you put it in there or not. I'm gonna just pull that one out. Those 4 points just don't exist. So you can give it to them or you cannot give it to them, it won't really matter. That's not a big deal. The modify based on peer evaluations, if we didn't get a peer evaluation, that's probably gonna go away too. So this is actually gonna be worth 7 points less than 58, maybe 51. And these two included a video. Do you think the audience understood what they were saying? And were they able to answer questions? How much of that can be done during the presentation? Right, and you need to ask it to end, don't interrupt, let them do everything that they can do. So at the same time, you should do everything that you can do on your rubric during the presentation, and you should mark, accurate measurements. Somebody questioned one of the measurements from outside earlier. You should put a little notation in there, put in 3 question marks or something, so that you remember to go back and ask a question. And detailed labeled drawing, did they have that? Mm-hmm. Give them the points, slide down to the next thing. You may have to go up and down, or maybe they set up their presentation to follow exactly along the rubric, and they did their whole presentation in the same order. Okay? Not bad.
Yeah, what?
You're off the hook. Who's next? And how are you going to get it to project? Oh, do you think there's anything from the overhead on the video that we just made? Do you think there's anything from on the video that we just made from there? Half of the filing cabinet is on the video. That's a part of your audience. If you're going to use something over here and you're going to point at it from over there, that's probably not a great thing, because half of my body is on the screen and my left arm is not. If you're going to use that, you're going to refer to that, you're going to point at that, you should go point at that. That's a presenting thing, that's maybe not something you should have known when you got up this morning. Or maybe it is. I don't know how many of these you've done. You want the lights off or lights on? This looks like a lights on thing. If you're going to put things up there.
I don't want to wear anything, so somebody else can wear it. Because I don't want to.
I had to work on it.
This is a microphone, and it will track that.
So if there's 3 of us, we'll just push it right there.
Yes, you can.
Ron, you're not even in it. Get over here. When do you want me to go? Oh, he's just going. I can go right now? Yeah? Can I start?
Is everybody ready for it? Do they have a rubric up?
I don't know.
That's your job, to make sure your audience is ready for it.
All right,
As soon as
you're
they're
all ready
ready,
then.
you can go.
Guess I'm talking first.
Gravity is a quality that has all matter and is directly proportional to the mass, that is, everything has gravity. For example, a person has gravity but very little, while the earth, which is very heavy, has a lot of gravity. The gravity on Earth pulls you into the center with an acceleration of 9.8 meters per second. This means that if you drop an object, it will fall with an acceleration of 9.8 meters per second, regardless of that mass. That is theoretically that if you throw a boat from 100 meters in the air, it will have the same acceleration of a plastic ball if you throw it. The difference is air resistance, and when you're in a slide, that goes with that.
The distance traveled from the top of the slide down to the bottom is 13 feet 5 inches.
The height of the slide is 11 feet 25 inches. The slide is a simple machine called an inclined plane. Because of an unbalanced force, objects tend to accelerate down inclined planes.
Okay. If the angle is very big, the X force is bigger than the E force. In an angle of 45 degrees, the X force and the E force is the same. In an angle that is small, the X force is lower than the E force. Friction affect your speed as well. Friction is a force that occurs whenever two objects rub against each other. Without friction, someone could go down a slide very fast, causing injury. Okay. This is the equation for calculate the friction. This is the friction. Okay, what? The friction coefficient. It depends on which material is. This is the normal force. That is the force that is the force that is the E force. For example, here, when the E force is very small, the friction will be smaller than here because the E force, the normal force, is bigger. The biggest factor of friction is what you are wearing. If you wear jeans, you travel faster. Because it have lower friction coefficient. And if you wear shorts, you will likely go slow and possibly stop altogether. Because your coefficient of friction will be bigger. The person is at rest at the top of the slide. According to Newton's first law of motion, inertia is someone that stays at rest until he pushes, either by himself or someone else. After the push, he accelerates until he reaches a maximum velocity and stays in motion until he is stopped by another force. Velocity is the speed of something in a given direction. So when you are at the top of a slide, you possess inertia. When you pull yourself off and accelerate, you possess velocity.
When a person first sits on the top of the slide, he contains potential energy. Potential energy is any stored energy in existence in any object that is capable of falling or moving. As he begins to slide, the potential energy is converted to kinetic energy. Kinetic energy is any object in motion. The kinetic energy of a person sliding down a slide depends on how much the person weighs and how fast the person is going. No matter which way the person is traveling down a slide and no matter which angle, that person contains kinetic energy.
Time for questions.
Did you have measurements on like an actual side?
Yeah. You want them?
Yeah.
13.
The distance traveled is 13 feet 5 inches. That's the red part. I think it's red. And then the height of the slide, 11 feet 25. There's a drawing too, and a little picture to explain that last part. Is that it? You can go. No.
Can we give them points for that?
Yeah.
Okay, but what about a video of the slide working? Is that what this intended? Video of the swing working, video of the slide working?
It has some zero.
Can
I
we
don't
take
care.
his live drawing and his live explanation and use that there? Would that be fair? So he's doing an on-site explanation / demonstration? Then give him a 5 there. It's being recorded and submitting, we give him a 2 there. Was there a discussion on simple machines?
Yeah.
That takes me down to the 4 and the 3 that we're gonna skip. And then there's a 10. Video of physical on-site explanation or demonstration. That's a repeat, but you guys said that was really important because we had to have video and that was hard. So what do we do here?
Give us a 0. Don't care.
I don't know if that's fair.
I feel like we could give it to them. Because technically it says on-site explanation for demonstration, and then explaining everything and demonstrating it. Yeah.
So the drawing on the whiteboard
Yeah.
fits that, and we can go with that? Did we hear everything? So we can give them that. Did the audience understand?
Yeah.
Okay, so one of you 5 way back there, tell me what a normal force is. Any one of you 5, or you can get together and figure it out. Without the use of
normal
the computer.
force. Explain what the normal force is. DD 3273. 73.
I want you to tell me what a normal force is. Any one of you 5 or all
We
5 of
didn't
you
say
together.
normal force.
Yes, they did.
I didn't use the word normal.
The 2 girls said they did.
He did, but
We never said the word normal
That's my
force.
next question. One of you 2 girls tell me what a normal force is.
you can't. Simple as that.
What's a normal force?
I didn't even hear him
Is
say
it
The
that.
something-
normal force is the force that
It's like gravity.
This was just all added in just now.
Does
Right
it
when we
act,
presented.
I mean, if you push to the axis, the normal force is the force that the slide give to the object.
so which arrow is the normal force? Which of those 3 arrows is the normal force? Okay, and what's the one that points straight down? The arrow that points straight down, the vertical?
This is the gravity, and this
Gravity.
is the X force.
And then the X. That's gonna be the motion of the box? That's the resultant force?
Okay. Well,
It's explained pretty
This
well.
is physics class, right? So, what about that able to answer questions, and did the audience understand? And could I have done the same thing on the last one? And the first one? And all of them from last time? Could I have picked and pointed out on all of the demonstrations we've had so far? Including last week? So are we exactly where we need to be?
Yeah.
No, we're not. Are we gonna let things go because this is the first time around?
Yes. Very much so. Yeah, we should present.
You need to understand that that's me giving in. And then we can answer yes. And we can move on. Good job.
Okay. Sure, I'm
We have how many left? Is that all? Sweet. We have almost 20 minutes so we can fix stuff. It's okay. All right. Fix stuff is next. And how and where we do that? Is why teaching can't be done by robots. At this point, the goal of this unit was that you would understand the physics in a swing, a teeter-totter, a slide, and a merry-go-round. If I went to a textbook and pulled out questions about centripetal and centrifugal force that involved math, how many of you think you would even pass? How many of you think you could come up with a formula? If I gave you 5 minutes and access to the internet, could you get a formula? I would bet that all of you could find the formula. I would bet that almost all of you could stick in the numbers that we had, if those were available to you, for the 2 merry-go-rounds, and do some calculations. I would bet that all of you could do that with a class average of above a 70. I bet you could pass as a class. But I don't believe for 1 minute that you guys understand everything that this unit was intended for you to understand. Part of that is because it's your first problem-based unit. And humans don't do things right the first time. It's part of human nature. It's part of human learning. So I need to modify my plans. But I kind of think you're a little tired of playground stuff right this minute. Would that be true? You'd rather do something different and come back to this? Because you need to understand that force diagram that's on the board behind me. You really do. Oh, that's not an M. That's the Greek letter mu. That looks like a printing lowercase u, only on this side there's a little curly thing that goes below the line. This is in symbols in Word. You can find it. It actually exists. And it has several meanings in science. The one in the metric system is pico, 10 to the minus 9. But you guys don't understand metric system yet either. I suppose. in the next 20 minutes, I need to come up with where you need to go next. To start filling in the things that you don't know, that you do need to know. Would it be, would I be correct if I said you don't know hardly anything about the metric system? If I asked you to not answer out loud, but to tell me how long this demonstration lab table is in the metric system, how many of you think you could get within 25% of right?
Roughly 2 meters.
Roughly 2 meters. I'd say that might be within 25%.
Meters go with yards.
A meter is how long?
Meters go with miles. Meter is roughly is like 100 millimeters.
I'm officially over it. No. Not just going to take it forever. So you will get a project based on the metric system, and that will be designed to ask you to understand the metric system. You will do a better job of presenting. You will do a better job of, how's that design cycle thing go? What's the first step? Good answer. And then? Yes. And brainstorm is to pull everything out of your brain that you already know that's even kind of close to like it. It's kind of related. Throw it down, right? Get everything on paper or in a Word document. And then you research. And your research has to be documented how? Yes, but how do we prove that you used a resource? In what format? APA format. So you do know what's expected, right? That's something that you can bring and actually get paid for, right? And next, we build. And after we build, we test and evaluate. And then we modify based upon our test and evaluation, right? How much of the stuff that you have completed is in Edmodo so that it can go in a gradebook? Like none of it, yeah. We should make sure that everything that you've done so far goes into Edmodo. Is there a spot for you to put your second project when we flipped and took somebody else's and modified it? No, there's no place to put that yet. I will take care of that as soon as I get done talking here in a minute. But you have a place to put your final project and your research and everything you used to complete it for the first time around. Correct? So you should do that while I make a place for you to put everything for your second time around.
So the ones that you already have up, we put the first one?
Yes. The ones that are up there, I need your first project. The ones that you did today go in a spot that I'm about to make. That should be called what? Playground Physics 2? Does that work? I bet you can. Everything that you have that is physical, that needs to be handed in needs names on it and needs to be handed in. Like Hannah turned in her references for chemistry. Everything that is digital can be put into Playground Physics final submission for your first one. Playground Physics rubrics, all of the rubrics that you have done. So, 4 groups? 5 groups? I don't remember. 4 groups. So you should turn in 4 of those, one for your group and one for the other 3 groups, into that Playground Physics rubrics. You pass them all to each other. That's an okay thing. Did you get all of the email addresses that you needed?
No, yeah.
I can put them into that. I should put them into the About Me. You want to email everybody's rubric to me and then have me email them out to everybody else?
We already emailed them to everybody else.
No. I need them in Edmodo so that they're there forever, so that I can go back to them a year from now if I need to. Cassie? That's going to be an issue. You're going to bring them up here and I'll take a picture of them. Hang on.
Mickey, are you emailing him or turning in this part?
Sorry.
What should I give him this? Do you have a second one? This is the first one.
Hey.
Quick picture manual.
Yeah, go for it.
Here you go.
Open it, see if it's the one with the lens on it. Seriously, cooking mattresses. Wouldn't that be fun? We would learn. We would epic. Those are for chemistry.
So the Playground Physics 2, we just put the presentation we done.
The stuff from today.
I haven't this.
Yep.
I haven't this. I don't know. I don't know how to do this. No.
It's okay.
Or-
This time. We'll figure it out for next time.
The ones that we graded or the ones that we got?
Nikki. What is that?
You should put in. Hang on 1 second. Did you concatenate? Did you grab the tabs and pull all the tabs into one file? When people sent you rubrics, did you put them all together into one file? You need to do that. Do I need to show you how to do that? I need to demonstrate? It's really not hard. You left click on the tab, you drag it over and try and drop it right on top of another tab. And then you have 2 files mashed into one file.
So if we give you those papers, we're good.
I suppose for this time, yes.
Panther bread.
That's not one. I don't think there's enough food here.
Yeah, but they got yelled at, so it might be more.
Yeah, they got yelled at. Like, you get something.
Nikki, do I have anything I need to do? Yeah.
Come on. It's on the wall for now, but it's headed to Edmodo in a second. and it will be in the About Me assignment.
Seriously, like, I'll look up a recipe and everything and find out who's gonna make this.
Are you ever going to let go of that?
Or cookies. You can't make bacon with a different, you just fry bacon. You don't. No. Actually, I like bacon in certain things now.
You'll like them in tanking, yes, so. Yeah, I don't know, I was like.
No, I figured out why I don't like bacon. I don't like bacon because I don't like my dad. He loves bacon. So everything he likes, I hate automatically. Wow. Well then.
In the About Me assignment, as soon as I unfreeze this,
Pumpkin cupcakes.
you can see the physics emails, and you can copy and paste from there. And when I go up here
Okay, can we please?
to Playground Physics 2, the stuff that we did today, really? Holy slow. 3 of you have turned that in. Your Playground Physics rubrics, 2 of you have turned in. You wanted me to show you how to concatenate. See all those tabs at the bottom? If I was to open a new spreadsheet, it opens up in a new window. If I was to shrink that window and change this, so that this tab says concatenate. If I want this inside of that, all I have to do is point at it, left click and hold it, drag it over here. Do you see the little tiny arrow right there? That means it's going to go in between those two. And if I pull it a little farther, it'll go right there. When you see that little tiny arrow, if you let it go, it'll move over there. So you can put all the rubrics from the whole class into one file and then send me that one file. That's the way you're supposed to do that. I will spend some time this weekend grading your stuff, so your grades will most likely be changed by Monday. You have seen your evaluations, and I have not. I'll take pictures of these during study hall, and you guys will come get them, or not.
Study on here, right?
Yes.
Oh yeah, we won't be here.
That's right. You guys are like headed to lunch and leaving at 11:30. And that's going to leave like 9 kids in the whole stinking school. Most of them are freshmen.
You got Austin though.
Are the freshmen out for stuff?
Yeah. Some of them.
We had a whole class in Armor. Our seniors aren't out for hardly anything. There's like 2 seniors that are out for anything. Nobody out for, 1 out for football, 1 out for volleyball. The end.
How many are there?
No, I lied. There's 2 out for basketball.
How many are there in the senior class?
15, 14 or 15.
That's like our football.
They're just, they didn't wanna. They never have wanted to. Is Nikki's